Well, hi, good morning. Thank you for joining me here in my shop. Today is January 22nd. Not quite as cold today, and apparently it's going to warm up in a couple of days to around zero. Not quite summer-like weather, but a lot better than the very, very cold weather we've been having. So, yesterday's video revealed, during yesterday's video, a couple of things got revealed to me. One of them is the lack of variation in the AVC voltage, which seems to hang around 1 volt. Strikes me it should be varying at least 5, maybe even 10 volts, but it's hardly changing. So I'm curious about that. I think it might be related to the tube that's in here right now, which I tested on my tube tester as being weak. I wonder if that's the factor. I have another tube to replace it. This one on the tube tester shows up as quite strong, so that's a difference, quite a difference. So we'll plug that in and we'll see if the AVC voltage begins to operate properly. The other thing is I'm in the midst of trying to decide how to wire the external input here, the phono input, for use with an iPod type thing. And the way it is right now is really very simple. It just adds it would add the iPod signal into the radio along with the radio's radio signal, and the two of them could coexist. Now it looks like the radio signal gets suppressed when you connect up to an iPod or something like that. The most interesting thing to me was I discovered that just plugging this cable in, kind of an odd cable, it has a phono on one end and clips on the other. Just clipping this in, but not plugging this into anything. So it's just two wires running parallel to each other through this cable, but not actually connecting in any way. And that really suppressed the output of the radio. So I think we'll take a look at that first and just kind of question why that would be. As for how to wire the switch here, I'm pretty intent on making the switch select either the radio output signal to continue into the amplifier, or the signal coming in on the phono to continue to the amplifier. So switch one or the other, as opposed to the way it is right now. That would cause an opening of the radio detector circuit, and I want to investigate that a little bit too before I don't think there's any problem in doing that, but what I think may not really matter. Let's take a look at the schematic in both of these questions that I have. Okay, so the first question was, well, I can't do anything about it until I replace this tube and see if we don't get a better voltage buildup in here. You know, maybe this indicates some other problem going on. Maybe a problem with these capacitors or something. I don't know. But the AVC voltage very, very steady. Actually, the AVC voltage is taken off here. So how these could have any effect, well, I don't know. We won't worry about it until we try switching the tube. The other one was, how come I hook up a piece of what is essentially a very small capacitor? The cable I was talking about you could think of it as a small capacitor. And I hooked it up. It would be so that was the audio input, and that's hooking it up right here, right onto here. So it's pretty much this. If we just pretend this is the piece of wire, and there's no contact at the end of the wire, and there's some amount of capacitance in here, tiny amount, and it's not that it's quieting down the signal that's coming through here. I haven't really considered that. It's quieting down the radio for reasons I find a little surprising. A little capacitor here? Well, maybe so. I mean, these are not big capacitors, are they? 100 picofarad. So these are not large capacitors. A cable like that might be, just taking a wild guess, 5 picofarad, which is not very much compared to these hundreds. 5 picofarad stuck on here. Well, unless I do more experimenting, I can't really conclude anything here other than what we just observed, and that is a few picofarads of capacitance in here. It just doesn't seem. Well, I wonder if it's detuning this in some way, and that's what's reducing the output. I don't know. We could play guessing games here for a while. The consequence of that is, well, if I put in a selecting switch that selects one or the other, then there won't be any consequence. Yeah, now what if I do that? If I put in a selecting switch, I'm going to want to break this. This is the wait a second here. How am I going to do that? So, because this isn't the way I thought it was in my head. I've still got the typical thing in my head, not what's really happening in this radio. The typical thing is the audio will be pushed into this line here, not pushed in way up here. I could consider all that. I could consider changing that. Now, we would just take this wire. We would put this sort of on the center pole of the switch. In one way it would click up here, and the other way it would click over to here. So if it's clicked over to here, so in other words, this is attached now to the top of the volume control, and this is gone. There's an open circuit here. This is open. If this is open, what would the consequence possibly be that I wouldn't want to have happen? Well, if you click this open, you lose the ground completely from here. There's no complete circuit here anymore. Be no action here. I think this would be no AVC voltage buildup. So what? Because whatever's happening in the output here is just cut off, because this would be open. I don't see how this could cause any kind of damage or ill effect to the radio. Even as it stands right now, the AVC voltage is not doing much, even as it now stands, he says, twisting the sentence around. Okay, looked at this enough. I think I'll mock up what I'm planning on doing, which is making the top of the volume control select either the phono or the radio, and this will leave this AVC line continuous without this attached anymore. Okay, I got it. I think I got it. Okay, plan is to operate the radio with the original tube that's in there now. So let's start the ball rolling here. Measure the AVC voltage on this meter, knowing that this meter will apparently put a bit of a load on the circuit. Draw it down a bit, or is it the capacitance of my wires? We don't know. Okay, so I'm going to go on the 3 volt scale. So we're just where we were last time, a little under a volt.
20 season feels like when they had Barry and Cody CC.
Tune. The lowest it falls is about half. Let me turn the antenna right off here. Yeah, about half, and let's put it on full. So we're supplying 114 volts. Okay.
It's almost all on the defensive end and what they're giving up. The chances against have skyrocketed for this team. And the blue line's not that much different than last year.
Okay, so under this condition, we're just under 1 volt here.
There's some bizarre stuff happening with this team right now.
Okay, now we're going to take out that tube. Make sure I'm doing the right one. Okay. Everything as it was. Power back on. Hundred and 14 volts again. This looks slightly higher than it was. Very slightly higher. To be honest with you, I was kind of hoping that we'd see a big variation here now with a different tube in there, but actually it's really operating pretty much exactly the same. So is there really a problem here? That's a good question. The first tube is a 6J8. Just look at what it says in the tube manual for a 6J8. Sometimes they'll kind of hint at what the range of grid potential, grid bias should be. 6J. Okay, this is a tube I have not encountered before or very many times. Anyway, 6J8 tetrode heptode converter. It's just full of stuff. Look at that thing. That's a busy tube there. It's got a triode at one side. Well, that's interesting. It has a separate triode, and then it has the pentagrid or 5 grid side. So this guy has a separate triode to drive the oscillator. I would imagine that's what you would use it for. And grid number 1 volts -3. Wow, we're at -1. That doesn't tell us what the range is. Grids. I don't like it when they write stuff. I like it in a chart. But I'll bet you there's nothing over here. This is the entire write-up. Okay, one more time. Meter volts. Typical operation. Heptode unit. Plate volts 250. Grids 2 and 4 100. 100 volts. Maximum. Grid number 1 -3. So grid number 1, it depends how you're using these. Grid number, which one's number 1? There's more than one number 1. There's a grid, looks like the same. The grid cap drives both the triode grid and grid number 3. If I'm looking at this right. Oh, it's very hard to see there. Where's my magnifier? My usual magnifier's upstairs. Okay, there we are. So, yeah. So the signal grid, so grid 3 and grid 1 on the pentode side are tied together and brought up to the grid cap. Grid number 1 is separate and goes to, how far we got this wrong now. Pin 5 has the 2 grids and grid 1 on the grid cap. What does it even matter, Jim? Why are you so focused on that nonsense there? What we're interested in is, well, we need to know which grid is being used for what. Well, the grid 3, son of a gun. I can't even keep two things straight here. So grid 3 is on pin 5 along with the triode grid. So grid 1 is on the cap. So if we're talking about grid 1, that's usually where you would have the oscillator fed to. Grid 3 would be the signal grid. So can we find grid numbers 3 and 4? Well, they're giving a current for grid number 3. What am I getting? I'm not getting anywhere reading this. This is not helping me at all. Yeah, I am not getting out of this what I want to get out of this. The only grid voltage it talks about, grid 1 minus 3 volts. Didn't help. That didn't help at all. So the other tube that's in here, that is being controlled by the 6J8. I'm looking at the right tube, right? Yeah, 6J8. The other one is a 7B7. 7B7. Okay, see if there's a hint on that. 7. What I'm trying to find out is this normal, a bias that hardly changes? I don't think so. Remote cutoff, pentode. Glass lock-in type used for RF IF amplifier. And in radios employing ADC. So this is designed for variable amplification based on the bias level on the grid outline. 15. Tube requires lock-in socket. Heater volt 6.3, 150 mils. Plate volts 250. Grid number 2 volts 100. Grid number 1 minus 3. Grid number 3 connected. Grid number 2. Plate resistance, transconductance. Transconductance at grid number 1. Volt. Oh, here we are. Here's something. Transconductance at grid number 1, voltage of minus 40 volts. So here they're giving you a operational information with a bias of minus 40 volts. 10 micromoles. So I think what they're trying to tell you is that you get up to minus 40 volts, you've pretty much stopped this tube from amplifying much. The application of this type is similar to that of the metal type 6SK7, which I'm very familiar with. 7B7 is used principally for renewal. So, minus 40. An easy way to interpret that is the bias can go all the way from like minus 1, minus 2 volts, all the way up to minus 40 in order to make that tube throttle properly. Well, there's no minus 40 happening here. We're not getting anything. I think something is wrong. I think something is wrong in the radio. Let's take a peek at the schematic and just try to take a guess as to what it could be. Oh boy. Okay, here we are. So we're talking about the bias on these two tubes, which is developed by these diodes and then conveyed along this wire past the input, which is what we've been talking about, onto the other side of this large resistor. There's virtually no current flow in here because it's basically an open circuit to this grid wire. It's just open. So there's no voltage drop here. So whatever voltage is here ends up here. Now I'll take that back. There is some current flow into this capacitor, charging up this capacitor. So yeah, there is current flow here related to this capacitor. Not quite true what I said before, but that happens. Okay, what of it? Well, how would you ever get 30-40 volts on here? And typically my experience is 10 to 15 volts develop in these circuits. Well, you'd need that much voltage coming out of here. You need a signal coming out of here, that kind of voltage on it. Now what could ruin it? Well, clearly if these capacitors are not performing properly, if you've got one of them here, it's just between the circuit and ground. So if for some reason this thing has gone way off, what about this resistor going way off? Well, the resistor goes off, the filter stops working. None of this is affecting the DC voltage up here, though. Would it? Would it? Well, you know, short circuit. This is solidly short circuited here. Well, I think we'd have a dead radio offhand, but I just have trouble understanding why the voltage is not varying much at all, yet it's not zero. It's possible it's not zero because over here you could generate a voltage. Perhaps a little self-biasing is taking place. Is that what we're seeing? Maybe we're just seeing a self-biasing voltage developing over here. Minus a volt would be typical of that kind of stuff. Then it would vary just a bit. You get a stronger signal, give you a little bit higher self-biasing. That would suggest this is open. How do we know this is 2.2 megohms here? If this were open, then I'd still be on this side where I've been making the measurements. I would see all kinds of variation. But I have measured both sides and found them to be basically the same voltage. So I think I'm barking up the wrong tree there entirely. And this thing is isolated from ground by this big resistance here. So you're not going to get any zeros up in here. How do you get it all the way down to 1 volt? Because I see, like just about everything that follows the word because works if the radio is not performing, but the radio seems to perform quite well. So I can't even finish my because sentence. The radio appears to be performing well. Appears to have too much volume. The reason I say that is I can turn it right down to 0 and still hear it. That's proof of nothing. How do you get this to happen? Or how do you get it not to happen? So I got a lazy finger there. I keep clicking my mouse by accident. How can you? I don't. You know, this isn't a complicated circuit. How can you? Well, you know, what can happen here? This is solidly grounded. Trigger finger. Well, the only components really are right in this area. Well, I'm gonna have to find these and try to check them. Well, that's about the best thing I can do, and maybe even check this too. Why not? Okay, check a bunch of components as best I can without removing them from the circuit, which is tricky. Let's see what we can do here. So I was taking a close look at the volume control here, trying to match up what we see on the schematic, and I see something odd about this volume control, which maybe I'm just not getting a good look at it. So I thought I'd turn on the cameras, and we'll use the you know, I call this a close-up camera, and a number of you send me emails. What camera is it you use for close-ups? Look, it's not really a close-up camera. It's just another webcam. This is called a Cinema from Microsoft. Cheap camera, $60, $70, $80, something like that. The whole thing about it is it just focuses really close, and so you can use it up close. That's all there is to it. There's a higher version of this called the Studio. I have one here. It does not focus up nearly as close. And my other camera, which I can show you by doing this, just because so many of you are curious about what I'm doing. That's the other camera I'm using. It's another very common camera, but see, it's physically large. You can't get it up close to things, and I'm not so sure it focuses as well as this guy. We're looking through now. Let's carry on. What I want to look at are the terminals here. Because with my eyes it looked like only 2 of them had connections, and that would not be right. But I think there is actually 3 connections there. Yeah, I was fooled. So the wire is just soldered on very low on the one terminal. Doesn't look like it's soldered very well. The other two. So one of these is going to ground. It's probably this one here. Yeah, I got the autofocus is not helping here. Okay, but I'm pretty sure that one must be the ground. Okay. Yeah, if there were only two wires going to the volume control, then we would have a weird situation in this radio. So what we're going to find out is that a ground? I'm going to shut the radio off. Okay, ground. Yes. Ground. Yes. Ground. No. And of course, okay, so we have the lower one. The right one here is grounded. The other one is the one that's conveying the audio. Actually, it's coming the other way. I'm doing this backwards. So I'm trying to follow that wire now from the ungrounded terminal up to where this RF pi filter is supposedly located. Okay, so that wire, you know what, I should keep the other camera going here. I'm just gonna have to put up the focus situation. The other wire, so the one that's looping around is looping around and reaching the center terminal on the potentiometer. The other wire is the wire that's going, what? Wait a minute, going in the box, going into the IF can. Oh. So in this wire there should be a resistor and a couple capacitors. Is there another wire in here? I don't think so. This does not look at all the way I described it. Come on, camera. Yeah, so this is the coming into the volume control terminal. The wires coming out of the IF. This would suggest that the pi filter is inside this can. Darn it. I don't think I really want to poke around in there. You know, this could be a case of, well, radio works even though its behavior doesn't seem quite right. It's working, and what is the problem anyway? Loss of automatic volume control with the radio stuck on high. Well, your volume control can help you with that situation. Better than having it stuck on low. Okay. What I'm saying is I don't think I'm going to be able to resolve the apparently weird AVC voltage, or lack of AVC voltage, really. Huh. How can they hide this stuff in the can? Would they really do that? That's not normal. Let's look at the schematic again here. Okay, so I shouldn't say normal. I should say that's just not common. All this stuff is inside the can. Now wait a minute. Wait a minute. So we're coming off the top. Yeah, this is the wire coming from the top of the volume control, disappears into the side of the can. So assumably all this is inside there, along with the coils and the other trimmer capacitors. Well, it's what it looks like. I don't know what else to say. Can I mean, I can't follow this any further this way. That's it. They bring a wire in to the to the can. Yeah, I don't know. I can't find these parts. They must be in the can. That must be the situation. Are these even responsible for the effect? I can't even see how these would be responsible for it offhand. Because anything seriously wrong here, these were shorted, that was shorted, or this was shorted, I think we'd have no output coming from this, and no audio output. So these can't be shorted. So if they're open, that means the RF filter is not working well. What's the consequence of that? Yeah, pretty silent. I don't know what the is there a terrible consequence? Loss of output, I suppose, maybe, because you're not getting a signal ground placed here. The signal ground's way down here. You'd have RF all through this. It'd probably be a messy affair of some sort. I think it's, and why would this one be in trouble? This is not carrying heavy current or anything like that. It's really not very likely this has gone off. What if it did? So this one totally open. Well, you'd have no signal getting down. You'd hear nothing. You'd hear nothing. Nothing can get through here because of the ground in the middle. So you'd hear nothing, and the AVC voltage would be, well, it's coming from back here. So you'd still have all that, but you wouldn't at the same time. If this is open, well, you'd have a signal ground here. You'd build up a lot of DC right on here. And some of it would be back here. I think you'd get very high DC. I don't know. I can't be sure. I'm not going to experiment. Okay, that's the end of that issue. Don't know what to do about it. Doesn't seem to be easily within my reach. Doesn't seem to be having an impact on the operation of the radio. A very negative impact. You can't compensate with the volume control anyway, and just take manual control in that sense. Radio is very sensitive. What if you hook up a whopper of a signal onto the antenna? Well, I kind of have a whopper of a signal on this antenna. When I'm using the system I'm using, the antenna I'm using, it's a strong signal, so it's not causing a problem. So, okay, AVC, the whole thing's just going to stay the way it is. I can't do anything about it. Doesn't seem important to do. Well, okay. Now, next thing. What about this? What about the switch? What about selecting? What about opening this circuit? And I'm going to experiment with this. I'm going to set it up the way I think it should be, and then we're going to try it and see what happens. Good. Okay, here's what I'm going to attempt. I'm going to take this jack. This is a switching jack. It has a switch built into it. So when you plug in the cable, notice this is a stereo here, but this is a mono device, and it'll de-stereo this if you plug it in. It operates a little switch in here, which you probably can't really see it, but a little switch. That switch is going to take the place of the manual switch that's on the board here. So you don't need a switch, just plugging this in will switch off the radio signal from reaching the amplifier. That's the idea. So to do this now, I need to find a 3-wire cable. Oh, look, I happen to have one right here. How do you like that? So I'm going to use a 3-wire cable. The difficulty with this, or the problem with it, is I'm extending a somewhat sensitive wire out of the radio. This green one here is going to be extended all the way up through the cable to the ear phone jack, or the jack I should call it, and then back. That might introduce some problems with hum and stuff like that. So this may not work out all that well. I have to set it up. So I kind of want to set it up a little bit temporary to find out. That's what's next on my hit parade. Temporary setup. See if it doesn't cause problems. Is that a double negative? Okay, ready for a test. So I have the jack wired up. I have the switch incorporated. The idea is plug something into this jack and it cuts the radio off. That's the idea. That's the first thing we're going to test. Actually, we're going to see if the radio even comes on, or did I boob it up in some way. Let's find out. Okay, so volume is low. And we got to plug it in. Here we go. Volume up a bit. And the antenna's still connected. Come on, radio. Please, don't make me do this again. That's good so far. Now, the concern here is I've now taken a wire which is just running in the back here, and I've had to extend it all the way out to the end and back in a sense. So, is it picking up noise now?
Level-headed, I think.
It's hard to tell because there's noise in the broadcast sound anyway. So, the signal level on here is quite high. It's the maximum output of the radio circuit before the volume control. So it's quite strong. So would noise be a factor? It doesn't seem to be.
Here's a good news story.
Oh,
From another
good news story.
Let's call it blue-collar, hard-working city. The Motor City. The Detroit Lions go out. The Tampa Bay Buccaneers, they get to the NFC Championship game. What a performance. Jared Goff, Jahmyr Gibbs.
Okay, next test. If I plug in one of these plugs, then the radio should just cut off. I'm not going to plug it into a radio yet, just an open plug. Plug it in here and the radio should go off. Yeah, it's trying to go off already. I'm trying to not. It's plugged in. Radio's off. Turn it up. But it's still sneaking a little bit in there. How it's doing that, you got me. But that's only with the volume very, very high. So, checking the volume levels here, we'll pop this out again. I have nothing to be afraid of, but I'm just automatically afraid.
A lot quicker than people thought.
So,
They revamped their
so that's a radio listening volume.
They added a weapon on offense.
Son of a gun, you still hear it. Well, let's go further. We'll now plug this end into my radio here. Just before doing that, because I am such a chicken, just going to make sure there's no voltages there. I can't believe you can still hear this radio playing. Yeah, laugh at me. Any voltages anywhere. Look at that. That's almost certainly the AVC voltage showing up again. I mean, it's bound to be there. Let's get my finger off of it. This is not the neatest way of doing this. Don't want my fingers touching it. It's a negative voltage. It's got to be what's being developed coming out of the IF. It's that strange situation again. Okay, now we're going to plug it into the radio with the radio turned off. It is off, isn't it? Let's tune something in here. We'll pick FM. FM. Don't play too much of that, or a copyright hit comes. Okay, I'm going to turn this up a little bit. Wow, you got to turn it a long ways to boost the radio volume. So there is a bit of a buzz in there. But of course that's what this plugged in. So we have even more wire extended out. Okay, this is going into the earphone. It's not the same as what I was working with last video. I was using a line level output. This is an earphone output. Somebody's at my door. Okay, I hope I remember to edit out all that deadness. Someone's coming to pick up the radio. Gone away with it. Okay, so we are in the midst of getting ready to plug this guy in, this radio in as an alternate source, or an auxiliary source, I guess might be a better name. And I was just saying that I'm plugging this into the earphone jack. It's hard to say what they've done with the earphone jack in a radio like this. In terms of the output impedance. So let's give it a try. This will also, this connection here will short any stereo-ness, because this is a stereo plug, and this is actually a radio capable of stereo in the headphones. There's a button on the side here, a stereo mono, and the button is missing. I've never ever tried pushing it. It's another yard sale special. Oh, look at this, line level output and headphones. Oh my gosh, let's go into line level output. Here we go. If anything, that got a little bit quieter, and some of the buzzy noise, and very hard to hear, went down a little bit. You probably didn't even notice it, but I still hear the radio. I have an idea about that. Well, that's not going to work. Okay. Is there some way to turn the speaker off? No, there is not. Huh. Except to push something into the headphones. Yeah, let's try the headphones. Still playing. Playing this now. Oh my gosh, I can't let too much music go or I'm going to get copyright trouble. If I do get a copyright hit, what I will do is I'll be chopping little pieces of the video out. So if that's what's happened and it seems kind of stuttery, that's what's going on. Now I'm just going to... Wow, it's just always there. Wow. Of course, you can just tune the radio, it will disappear. So don't forget that. Okay, I'm going to pull this out and see how much louder it gets. Let's try that again. Normal listening level. And then this. That's distorted. Jeepers creepers. The two volumes are kind of competing with each other. So here's my idea here of what's happening. Why can we still hear this radio even though the output from the IF is cut right off? It's just open circuited. Well, there is another connection to the detector that, you know what, I'm going to put this, let's put the schematic up and we'll continue talking about it. Okay, so this wire here, this circuit here, which is carrying the audio, is open circuited at the jack. Yet we can still hear it. But look, there's also this wire, which is going to be carrying all the audio. Yeah, I think so. I think it's carrying all the audio here. Comes along, meets up with this capacitor. If there's any audio in this circuit, I would imagine the hope is it's killed by this 0.05. This is an odd arrangement how they've done this, to me. So this 0.05 is very important. Now I didn't do any replacements. There's a couple capacitors in here that did not get replaced. Could it be one of two things has happened? Wrong size has been installed here in a replacement. It's not very likely. More likely, this is an old capacitor still, and it's lost its capacity. So it can't do what it's supposed to do. And you know what? That would explain too. how to explain the weird AVC stuff going on in this circuit. Where's the AVC voltage? It's in this sad capacitor. Okay, so number 34, is there a part layout that's going to show us 34? And we look, well, this is the 52. We don't want to look there. We want to look here at the 49. And I forgot the number now because I said a number. The number is 34. Looking for 34. Ooh, is the numbering different? Maybe. Yes, it is. Okay, so we're not looking for 34. We're looking on the correct schematic. It's 32 up here. It's the same thing otherwise. Yeah, 32. So look for 32. Boy, am I ever going to get this right? 32, tubular. Yeah, okay, that would be it. 0.05, 32. Come on. Hey. There it is, 32. This guy here. So there's a terminal strip, 2 sockets, and in between is this capacitor on a bit of an angle. And where does it, doesn't show the connection, so we don't know where it's going. But I think I see it. I think it's been replaced. 32. Let's look. So I think this is it here. If this is it, then should go to ground. It appears to be going to a, yes, it's going to a grounded terminal on one side. The other side is going to this terminal on the tube there. That's the IF tube. You know, they'll install this capacitor where it's convenient, because there's lots of places you could install it. So this would be pin number 1, 2, 3. Pin number 3. And it looks like it's got a resistor connected to it down under there. Pin number 3 on the what tube is that? Pin number 3 on what tube is that? Let's take a look. So the tube I'm talking about is the I got 4 in a row here. It's this one, and I'm looking at, I counted them. What's this? Oh, this is a part. So there's 1, 2, 3, 4, 5. I've lost total track of what I was doing now. So let me look back in the radio and count pins once again. Okay, so I was looking at the wrong tube? No, looking at the, that's the correct tube. And we're talking about pin 1, 2, 3, 4. I'm sorry, losing my mind here. Let's try it again. 1, 2, looks like 3. 3, and it has a resistor on it. It's 3. You know what? I haven't got this right at all. I don't think I'm. So let's just try this again. So the capacitor is located. Yeah, it's located in this area. I mean, it's been replaced, so it's not in exactly the same place it would have been. And it's making a connection to a terminal strip that they haven't shown, which is right in here. That's kind of weird. They didn't show the terminal strip. That's just a little surprising. Okay, but for sure that's got to be the capacitor, I would think. For sure, I would think. I don't see this little part in the radio. Or what are these? 21 and 28. 21 resistor and 28 resistor. 2 resistors down in there. Well, I don't see them. Okay, we're not going to worry about that though. I've got enough to worry about right now. He's sorting this out. So counting once again. to get this right. This is the last time I'm going to count it, making sure I'm looking at the right tube. We've got, I'm pretty sure it's 3. 3. 3. Now, is that going to help me up here? 3. It's not going to help me. 7B7. 7B7. B7. And I think it's pin number 5. 1, 2, 3, 4. Did I? No, pin number 3. 1, 2, 3. Oh, 3 is a screen. Is it really 3? The layout diagram, does it actually show the way the tubes are installed? So if that were the case, then we're looking this way. And I better start looking at the right tube here. Oh boy. Okay, sorry about this. It's kind of a draggy video when this kind of stuff happens. So we're going in on pin 3 here. That certainly looks like pin number 3. And that is the, how confusing is this, 7B7. The 7B7 pin number 3 is the screen. So this capacitor is hooked up to the screen there. So, but according to the layout, that's supposed to be the AVC capacitor. Why would it be hooked up to the screen of a tube? Because I got something terribly wrong here. I must have something wrong. I'm not counting the tube pins correctly. I'm not counting the 2 pins correctly. Really? Oh my gosh, this is dragging out. Dragging out a lot. Let's just try this. Okay, so this is the capacitor. Sorry about the focus. That is the tube. That is the pin. You can see the ground lug on the center portion of the pin. That's opposite to where the key is, underneath the cable I put in. I'm just trying to positively see the key. It's not working out for me. Can you not see that from above? Let's look at this one. I'm pretty sure you can see the key. Now, do you think I'm going to get a copyright hit because that music is quietly playing there? Yes. If I can hear it, YouTube can hear it. So I'm going to stop this video, sort this out, because I'm going to have to cut a whole pile out anyway. I don't like to do much off of video here. Let's just take the longer shot. So I decided this is probably not the AVC capacitor because it's connected to the screen of this tube. It's doing something else. So I thought, well, how about this? We can find the AVC capacitor. It's got to be on this terminal here. This one right here. You can see the 22 or 2.2 mega ohm resistor here. So on the other side of it is the 2 grid circuits, and the AVC capacitor should be connected here. There's nothing connected to this terminal except this wire. And while I was tracing this wire, this happened. There's a disconnected wire here. this wire. Wow, this wire is traveling up into the IF can. Oh my gosh, what has happened here? So this is hidden. Looks like it was probably tied to one of these terminals. What is it? How can this radio operate with this wire hanging out here? And that's going to be the end of the video for today. Oh my gosh. Oh my gosh. This can't be. Can't be a wire not connected. Now maybe it had fallen against the chassis and it grounded. Maybe it's supposed to be grounded. Boy, maybe, but I doubt that. Holy smokes. Oh my gosh. How can this... Okay, so another day on this radio. Tomorrow we'll look at this wire and try to sort it out. Maybe this explains the whole AVC not doing much thing going on. What a day. Hey, thanks a lot for watching. I hope you're getting a kick out of it. Yeah, I'm getting a kick, that's for sure. Thanks a lot for watching. And thank you for the super thanks. See ya.